Hi, I'm an old guy and I do maths. We've been asked to calculate what is a definite integral. The giveaway that it's a definite integral is the presence of these two numbers here. Now, sometimes it won't be numbers as you know them. If you've got a trig function that you're trying to integrate, it may be something in terms of pi, etc. Anyway, let's have a look at this. Now, I don't know about you, but I usually find integration a little more difficult than differentiation because, in a sense, we're trying to put the genie back in the bottle. Now, when I look at this, two things spring to mind. There's a fairly long way, well, there's a longer way of doing this, a thing called U substitution. And then there's just staring at it for a moment and thinking about what's going on. If we look at this part of this integral, we see something interesting. Now, if I were to take this, e to the x squared minus x, and differentiate it, this is what I'd get. The rule says that I differentiate this, which gives me 2x minus 1. You can see where this is going. And this remains. Look familiar? Yes, indeed. So the integral of this is this. So now we need to calculate its value. So let's do that. We'll put 2 into this to start with. So e to the 2 squared minus 2. So that is e to the 4 minus 2, that is e squared. And what we do then is we subtract this with the value of 1 standing in for x. So what we have is we have e to the power of 1 squared minus 1, which gives us e to the power of 0. What looked fairly challenging is in fact remarkably simple. If you recognize this and the process that was gone through to get the whole integral. Anyway, the result is e squared minus 1. Anything to the power of 0 except for 0 is 1. That is our answer. Quite straightforward. Thank you very much for watching. I should say that I'll do this another way another time, I think, just to show you how the substitution method works. Anyway, thanks very much for watching again. If you found this useful, please like and subscribe, and I'll see you next time. Bye.